Today we're just looking at the greatest common factor portion. Okay, so does everybody see where we are? Yeah? I would take your white packet. Once we're done with these notes, I would take the white packet from yesterday and staple it right to the green one. Take the white one and we'll staple it right to the front of the green one. Okay? All right. So it says a factor is a number that what? Well, I just told you today at the beginning of our notes. A factor is a number that divides. Good job, you guys. A factor is a number that divides another number completely with no remainder. I filled out notes up front if you want to, if you don't, or take, you're amazing. Thank you, ma'am. Okay. So the first thing that we want to do is look for our factors of 128 and factors of 144. So in my calculator, I'm going to type in y equals 128 divided by x. And then I'm going to press the second graph button. And I'm going to get all of the factors of 128. Tell me when you're ready. I'll start you off. 1 and 128. This is calculator active. Pick up your calculator. Let's list out some factors. What else? Yeah, 2 and 64. Good job. 4 and 32. 8 and 16. Your next one with whole numbers is 16 and 8, right? It starts repeating itself. So this is my list of factors. Once it starts repeating itself, you know that you're done. You've listed them all. So now let's go to our calculator again. Y equals 144 divided by x. Second graph. And let's list our factor pairs of 144. Seamus, you got them? You want to share them out? 2 and 72. Perfect. 3 and 48. 4 and 36. 6 and 24. 8 and 18. Keep going. Two more pairs. 9 and 16. 12 and 12. So we've come to a repeat, right? So that means they just kind of loop back around. So this is all of them. So we're going to define this common factor. A common factor is a factor. Remember, that means just a number that divides it nicely, that two or more numbers have in common. Okay. So I'm going to just underline common factors, and I never include one because everything is divisible by 1. So let's see. Both of these are divisible by 2. Both of them are divisible by 4. Both of these numbers are divisible by 8. Both of them are divisible by 16. And that is it. Those are my common factors. I just put an underline underneath them, okay? So I underlined my common factors just so I can kind of identify them. Okay, I just put an underline under them. We said that the greatest common factor is the largest, right? It's the largest factor that divides two or more numbers. So of all of those common factors that we have underlined, which one is the largest? So I'm going to put a big old circle around that. And I'm going to write that the greatest common factor is 16. Does that make sense? Okay. So factoring with a polynomial is when you write a polynomial as the product of two or more simpler polynomials. Remember, a polynomial can just be a number all by itself, right? So when we factor out a GCF, we divide by the largest term. That's the factor of all of the terms in the polynomial. So let's look at this first example. Example number 1 says factor. And we're factoring 9x minus 18. And it actually tells you that 9 is the greatest common factor. So we're going to factor out a 9. So I'm going to show you what that looks like. We write the original problem, 9x minus 18. And if we're going to factor out of a 9, that means that we're going to divide both terms by 9. So I don't care if you guys write it like this. Sometimes it might help you to put the 9 underneath every single term so you can actually see what's happening. We're taking out a 9. Now, just because we're dividing by 9 doesn't mean it goes away. It doesn't go away. It's going to become the number at the front of my parenthesis. So we're kind of doing the opposite of distributing. We're undistributing. What is 9x divided by 9? X. What is negative 18 divided by 9? Negative 2. We could check by distributing. We could check by using distribute. If I took 9 times x, I would get 9x. If I took 9 times negative 2, I get negative 18. So whenever you check, once you've factored something out, you can always go back through and multiply and check and make sure that what you end up with is what you started with. But this is what it looks like in factored form. This is factored. We took out the greatest common factor. So let's look at example B. You might need to use your calculator. Tell me what number divides both 56 and 35. So you might have to use your calculator and write y equals 56 divided by x and y equals 35 divided by x and go to your table and see what number divides them both. This is especially difficult if you don't know your math facts. Super easy if you know your math facts, but if you don't know your math facts, this is a really hard task. That's why knowing how to do it on the calculator is beneficial. So what number divides both 56 and 35? 7 divides them both. So I'm going to pull that 7 out. That 7 goes out to the front. Let's see. 56m divided by 7 is, right? What is it? 56 divided by 7. Isn't it 8? Yeah. And what is 35p divided by 7? 5p. Don't forget about your variables. So this is the factored form of 56m plus 35p. God bless you. What about example C? We've factored 24 a couple of times. Do you guys see the greatest common factor, the number that divides both 12 and 24x? 12. Yeah, we can divide both of these by 12. We can divide both terms by 12. So I'm going to pull my 12 out front. What is 12 divided by 12? It's 1. I would say the biggest mistake I see is when you guys see something like 12 divided by 12, you just like, oh, that's gone, and you don't put anything there. Remember, it's 1. And 24x divided by 12 is 2x. 2x. Okay? Questions about that? Do we feel okay with that? Okay, let's look at this next one. So the next one, I didn't tell you what the GCF is, but I will tell you that it's got a variable term as well. So what number divides both 9 and 15? 3. Okay. I'm going to give you a hint. The GCF of a variable is the smallest power of the like term. So what does that mean? Well, that just means that the greatest common factor of variable terms is the smallest power of the same variable, right? So what is the smallest power of those two variables? I have x to the 4th and x squared. What's the smallest power? Which one is smaller, x to the 4th or x squared? X squared. So that means that I can take an x squared out of both of them. That is what my greatest common factor is going to be. So let's see. 9x to the 4th plus 15x squared. And I'm going to divide both of these by 3x squared. So I'm basically pulling out that factor of 3x squared. So I'm going to move it outside of my parenthesis. And I'm going to divide using the quotient rule. I know that 9 divided by 3 is 3. And I know that x to the 4th divided by x squared. What does the quotient rule say? What do I do? When you're dividing powers and the base is the same, what do you do with the exponents? You subtract them. 4 minus 2 is 2. So 3x squared. 15 divided by 3 is a positive 5, and x squared divided by x squared, those just cancel each other out. Okay, those just cancel each other out. So this is the factored form of 9x to the fourth plus 15x squared. Alrighty, let's look at example B. Example B. So you might need to use your calculator. If you don't know factors of 32, we should know 24. We factored it like 3 times already. 32 and 40, what are some numbers? Put it in your calculator. 32 divided y equals 32 divided by x. Y equals 24 divided by x. Y equals 40 divided by x. What's a number that divides all of them? 8. Yeah, 8 divides all of them. So all of these can be divided by 8. What is the smallest power of my variable term? P squared. So we're going to divide everything by 8p squared. Divide by 8p squared. I'm going to divide by 8p squared. Okay. So 32 divided by 8 is 4. P to the fourth divided by p squared. Well, the rule says that if the base is the same, you do what with the exponents? Subtract. So what is 4 minus 2? 2p squared. Negative 24 divided by 8 is negative 3. P cubed divided by p squared is p. 40p squared divided by 8p squared. Well, my p squareds cancel out, and a positive 40 divided by 8 is a positive 5. This is my factored form. If you flip it over, we have one more example. One more example. Okay. It says the greatest common factor is the binomial factor blank. We have to fill that in. Notice that this polynomial right here has a factor of x minus 5, right? Remember, a factor is just a number that you multiply. This polynomial right here also has a factor of x minus 5, right? So let's see, what can I pull out? Well, I can pull out my binomial factor, which is x minus 5. So that's what I'm going to divide both terms by. I'm going to divide both terms by the quantity x minus 5. So when I do that, I have to think about what I have left. So when I divide this polynomial by x minus 5, I'm left with x plus 6 plus, right, there's a big old plus in between these. When I divide this polynomial by x minus 5, I'm left with 2x plus 5. Can we combine any like terms? What can we combine? So the x and the 2x is 3x. 6 plus 5 is 11. And this x minus 5 that I took out at the very beginning is still going to be out there. The x minus 5 that I took out at the very beginning is still going to be there. So this is the factored form of the sum of those two polynomials. Looks a little bit differently when it's broken up, right? Looks a little bit differently when it's broken up. So let's look at our second example, example B. And do you see anything that looks the same on both products? You're looking at the products independently, right? So compare this one and this one. It's not just m plus n, it's something else. Yeah, they both have an m plus n, the quantity squared. So if I divide both of these by that m plus n, the quantity squared, divide by m plus n, the quantity squared, what do I have left? I have x squared. What's in the middle of it? X squared plus y squared. Yes, ma'am. X squared plus y squared. So I'm just going to rewrite this as m plus n, the quantity squared, times x squared plus y squared. Okay. Ladies, do you want odds or even? Ladies' choice. Odds or even? Decide right now before you look. Doesn't matter? Okay. Gentlemen, odds or even? Even? Okay. So the gentlemen have the evens. The ladies are going to do the odds. We're going to modify for everybody. Gentlemen have the even number problems. Ladies have the odds. So notice that this is two. It goes all the way to number 16. So you are each going to do 8 problems. No area problems in here. You're each going to do 8 problems. Okay.